Is from the Washington Post. Headline reads, Earth is now trapping an unprecedented amount of heat, NASA says. The subhead, new research shows that the amount of heat the planet traps has roughly doubled since 2005. Doubled since 2005, contributing to more rapidly warming oceans, air, and land. This came out June 16th, 2021, and as indicated a couple of paragraphs down in the paper, the magnitude of the increase is unprecedented. The Earth is warming faster than expected. That's a direct quote from Norman Loeb, NASA scientist and lead author of the study, which was published in the journal Geophysical Research Letters. So let's turn to that paper in Geophysical Research Letters, published on June 15th, 2021. Again, there's a link at guymcpherson.com. The paper is titled, Satellite and Ocean Data Reveal Marked Increase in Earth's Heating Rate. Again, by Norman Loeb and 5 additional scholars. This from the abstract. Earth's energy imbalance is a relatively small difference between global mean solar radiation absorbed and thermal infrared radiation emitted to space. How small? Presently about 0.3%. That small difference between the amount of sunlight coming in and the amount of energy released back and out into space makes this planet habitable. It allows, through the greenhouse effect, for a warmed Earth rather than a very cold rock floating through space. From the plain language summary, climate is determined by how much of the sun's energy the Earth absorbs and how much energy Earth sheds through the emission of thermal infrared radiation, the amount coming in versus the amount going out. Again, turning to the abstract, we show that independent satellite and in situ observations each yield statistically indistinguishable decadal increases in Earth's energy imbalance from mid-2005 to mid-2019 of 0.5 watts per meter squared per decade. 0.5. Doesn't sound like a very big number, but it's a lot. This trend is primarily due to an increase in absorbed solar radiation associated with decreased reflection by clouds and sea ice, and a decrease in outgoing long-wave radiation due to increases in trace gases and water vapor. It's a little surprising to me that they're admitting that water vapor is an important greenhouse gas. It almost never comes up in public. These changes combined exceed a positive trend in outgoing long-wave radiation due to increasing global mean temperatures. So this is an important paper in that it points out how rapidly we have warmed the Earth, profoundly rapidly, half a watt per decade on average, over the course of the last 14 years. Now then, let's look at the other side of the coin, the side that is rarely mentioned, and in fact, I did not find this particular paper through a corporate media outlet, which is what I almost always start with in these science updates. I start with a paper from the New York Times, the Washington Post, or some other corporate media outlet, which leads to a paper in the peer-reviewed literature. This one, as nearly as I could tell, did not appear in any corporate media outlet, and it's not particularly surprising, given the topic. Instead, this paper was published in Nature Communications, a stunningly reputable outfit. Any of the Nature journals are. In Nature Communications, published online on June 15th, 2021, so approximately coincident with the other paper that I already mentioned. The title of this paper is Significant Underestimation of Radiative Forcing by Aerosol Cloud Interactions Derived from Satellite-Based Methods. In other words, satellite-based methods used in the past significantly underestimated the aerosol masking effect. Failed to report how much of the incoming radiation was blocked by aerosols from reaching planet Earth. The paper is by Heiling Jia and 3 other colleagues, and I'm pretty sure I mispronounced that. And it indicates that the clouds missed in previous work, clouds that held aerosols, missed in previous work, exert a strong cooling effect and are more sensitive to aerosol perturbations. By accounting for the sampling biases present in previous papers, the magnitude of aerosol cloud interactions increases by 55% globally. 55%. I was stunned when I heard David Attenborough in his latest film released point out that there was a 40% reduction in incoming sunlight as a result of the aerosol masking effect, or global dimming. 40%. I thought that was amazing. That was the highest I'd ever heard admitted from any corporate outlet. Turns out, here we have in a recent paper in Nature Communications, it's not 40%, it's 55%. In other words, the planet would be receiving 55% more incoming radiation from the sun if it weren't for the very strong nature of the aerosol masking effect. All right, so by switching to a different technique for evaluating aerosol masking, this paper came up with a much higher figure than I've seen anyplace else. And I should point out the profound coincidence here. By accounting for the sampling biases, this again from the abstract in the paper in Nature Communications, by accounting for the sampling biases, the magnitude of aerosol cloud interactions increases by 55% globally. That's a huge number, and it corresponds to about half a meter squared, negative 0.5 watts per meter squared. Now, let's turn to this previous paper in Geophysical Research Letters. The increase in Earth's energy imbalance on a decadal basis is about half of a watt per meter squared. That's a huge number when you consider that the total radiation striking the Earth right now, and has been up until 2005 apparently, has been for a few decades, was about 2 watts per meter squared. And now we're measuring half a watt per meter squared increase, or rather decrease, as a result of aerosol masking. Imagine if that 2 watts per meter squared that the Earth is currently receiving in terms of radiation striking the Earth, imagine that were increased by another 0.5 watts per meter squared. That's what we're talking about at the level of aerosol masking here. That would be a tremendous increase in energy reaching the Earth, far greater than anything I've ever seen reported before in the corporate media or in the peer-reviewed literature. This is a really important set of papers. We are overheating the planet, and the escape route of reducing industrial activity just won't work. It'll heat the planet even faster. I'm not excited positively about this outcome, but as much as the bad news keeps coming, it seems the bad news keeps coming. Thanks for staying tuned. We'll try to produce another one of these science updates in about a week.